Hello, everybody. Guess what? We are in our last week. With that, just remember that next week, technically school's still in, but next week is just a makeup week. So anything you need to finish, anything you need to get done, that's next week for you. So please reach out to me if you need quizzes codes unlocked so you can get those done. If you need any help, please reach out to me so I can help you get that stuff done and get us where we need to be so that we can end this quarter in a good way, at least grade-wise. All right, so today we're going to talk about factoring, and I'm just going to make a video to talk about, I have 6 different types of factoring on here that we need to talk about. So, switching it over here. So, factoring is super important as you move on. Like, it is one of the most crucial things to know to move into Algebra 2 and into pre-calculus. If you don't have it, it's going to cause you to have a lot of issues. You're going to struggle, so we need to make sure that we address that now and make sure that we remember how to do our factoring, because we didn't do a lot of factoring in geometry. So we're going to start off with this problem here. I've got 3x squared plus 12x minus 36. So remember, the first thing that we always want to do with factoring is you always want to check for a GCF. Is there something that this equation or this polynomial has in common that we could factor out? And there is. I could divide everything here by 3. 3 is divisible by 3, 12 is divisible by 3, and 36 is divisible by 3. So we're going to factor a 3 out. So if I divide this 3x squared by 3, I'm left with 1x squared, or just x squared. If I divide 12x by 3, I'm left with positive 4x. And last, if I divide negative 36 by 3, I'm left with negative 12. So then I can proceed on to factoring. So remember, the way that factoring works is we're going to try to take this middle term, this 4x, and separate it into 2 different terms that we could then use. So I'll keep my 3 out front here. So what I'm looking for is I need 2 numbers that I could multiply to get to a negative 12. Well, the thing that stands out to me is that I'm multiplying to make a negative 12. I definitely need one of those numbers to be a positive number and one of those negative numbers to be a negative number. And then I've got my negative 12 at the end. Those 2 numbers also have to add up to 4x. I need 2 numbers that multiply to make the negative 12 at the end, but still add up to make 4x. Well, the number that comes to mind is going to be 6 and 2, where 6 is a positive and 2 is a negative. So I'm going to have 6x and negative 2x, right? 6x times negative, or 6 times negative 2 is negative 12, and 6x plus negative 2x is going to give me positive 4x, making sure that that 6 is positive because the 4 is positive here. It's gonna be the stronger one. So then we can do something that we call factoring by grouping. There we go. So I would group these 2 together and group these 2 together, and then factor out GCFs there. So what I say here is x squared plus 6x, the GCF is going to be an x, right? And when I take an x away from x squared, I'm left with just 1x. When I take an x away from plus 6x, I'm left with plus 6. And here it looks like I'm going to be able to factor out a negative 2. So I'm left with x. That negative 2 is going to turn that into a plus and 6. What should happen if this works is that this and this should be the same. If it is, you did it right. And you're going to put your 3 here. You're going to put the one that's the same 1 time. And then these 2 leftover pieces, this x and this negative 2, that makes the second term, x minus 2. And that would be our factored version, 3 times x plus 6 times x minus 2. If you re-multiply this together, if you multiply x times negative 2, 6 times x, 6 times negative 2, and then multiplied everything by 3, you would go back to this original answer, 3x squared plus 12x minus 36. All right, going on to our next one. We are going to have a quadratic again, just like I just had. The difference this time is 5x squared plus 17x plus 6. The difference this time is when you look at this, there is no GCF, right? The only thing 5 is divisible by is 5, but that doesn't divide into 17 or 6. So I can't do this one by the same properties. I can't use the GCF to do it. So we're going to do the same thing that we did in the last problem. We're still going to separate this middle term. So I have 5x squared. I've got this middle term here, and this plus 6 at the end. I'm going to break this middle term into 2 separate middle terms. Now, this is where it gets a little bit weird. It no longer is just what multiplies to make 6 but adds up to make 17. In fact, you have to take this number up front and multiply it down here. What does 5 times 6 gives us? 30. So we have to come up with a number that multiplies to make 30 but adds up to make 17. Now in this case we're looking at a positive, so the only way to get a positive number is with a positive times a positive or a negative times a negative. But you can't add two negatives together to get a positive 17. That's just not going to work. So the only way we're going to multiply to get a positive and add up to get a positive is to have something positive and something positive. So now our focus is two numbers that multiply to make 30 but add up to make 17, and they're both positive. Well, I think we're going to be able to do 15x plus 2x. Right? 15x plus 2x gives me 17x. 15 times 2 is definitely going to be 30. And notice what I did. I aligned it so that the 15x goes with the 5x because those things are going to have a GCF. And I aligned it so the 2x and the 6 go together because those are going to have a GCF. So when I factor this by grouping, 5x squared plus 15x and positive 2x plus 6x. Remember, oh, no, not 6x, just 6. If there is a negative on front of that 2, you got to keep that negative with the 2. So over here, the GCF is going to be 5x. 5x from x, 5x squared leaves me with just an x. And 5x from 15x is going to leave me with a 3. Over here, what I can factor out is a 2. And it's going to be a positive 2. So I'm going to actually put that plus there just to help me out. I'm factoring out a positive 2. So I have x and then plus 3. Again, this and this should be the same. In this case, it is. So that's going to be my first term. And then you make a second term with the things outside, a 5x and a positive 2. So we're going to have 5x plus 2 as our second factor. And that would be my factored version. Again, if you remultiplied that, you would get the same answer, or the same original problem. So you could always go back and check your work. My next ones are going to be some factoring, difference of two squares, and difference in sum of two cubes. So the first one is 25x squared minus 16. This is one you want to practice memorizing. If there is two perfect squares, meaning I can square root the first thing and the second thing, and there is a minus sign between them, there is a pattern that exists every time. We do two sets of parentheses. One is a positive, one is a negative. And you look at the first thing. Well, what's the square root of 25x squared? Well, the square root of 25 is 5, and the square root of x squared is x, so 5x. You put that in both the parentheses for spots. Then look at the 16. Well, what's the square root of 16? 4. So I'm going to put a 4 here and a 4 here. And that's your factored version. 5x plus 4, 5x minus 4. Difference of two squares. The next thing that you could see is the difference of two cubes. So x cubed minus 27. When this pops up, this is one that we always forget. Everyone always forgets this one. What's going to happen is we call it the little big factor. You're going to have a little, and then you're going to have a big. This little one's going to have one sign, and that sign is always going to be replicating whatever's in the problem. So since this is a minus, we're going to put a minus here. The second sign is always going to be the opposite of whatever we start with. So if this was minus, this is going to be plus. And the last sign is always a positive. That never changes. So keep, change, always positive. Okay, so what we're going to do is we are going to figure out what the cube root of x cubed is. Well, that's going to be x. And what the cube root of 27 is. Well, that's going to be 3, because 3 times 3 is 9, and 9 times 3 is 27. Now I take these two numbers, and the first spot is going to be the first number squared. So x squared is x squared. The last spot is going to be this number squared at the end, so 3. 3 squared is 9, so I'm going to put 9 at the end. The number in the middle is going to be the product of these two. So if you multiply x and 3 together, you get 3x, so I'll put a 3x there. And that would be my difference of two cubes. Well, what if I had a sum of two cubes, Mr. Nakarado? X cubed plus 8. Similarly, we're going to do small, big. Since this is a plus sign, we're going to start with the plus sign. We're going to change the sign, and then always a plus sign at the end. Do the same thing. The cube root of x cubed is x. Cube root of 8 is 2. X squared is x squared. 2 squared is 4. And x times 2 is 2x. 2x. Maybe you're asking right now, Mr. Knock, well, can't I do like a sum of two squares as well? Can't I do like x squared plus 9? That doesn't work. There is no sum of two squares. There's a difference of two squares, but because a cube is odd, like the power 3 is odd, it works both negative and positive, so there's a sum and a difference of cubes. So just kind of keep that in mind as we move forward. One other factoring problem that you got to be able to do, and that is a factoring by grouping with a cubic function. So let's say I have x cubed minus 2x squared plus 4x minus 8. Well, if you understood the grouping that we just did when we did our separating the middle term, this is going to be easy. You put parentheses around the first two terms and parentheses around the second two terms and factor out. Well, the greatest common factor for this first two things is just an x squared. If I take an x squared away from x cubed, I'm left with 1 left over x. And if I take x squared away from negative 2x squared, I'm left with negative 2. Over here, it looks like the thing that I can factor out is a positive 4. If I take a positive 4 away from 4x, I'm left with just x. And if I take a positive 4 away from negative 8, well, that's going to have to be a negative 2. Negative 2 times 4 is negative 8. Well, this came out correct again. These two things are the same, so that becomes our first term. And my other two pieces become the second term, so x squared plus 4x. Sorry, plus 4, not 4x. And then you'd always check. If this is a difference of two squares, you'd keep going. Like if this was x squared minus 4, then I can make it x plus 2 and x minus 2. It is not, though. It is just the sum of two squares, so we're not going to worry about it. We're just going to leave it just like that, and we're done. So hopefully that gives you a good reminder of how to do factoring, and you can apply this and get yourself going in the right direction with those IXLs. By the way, I should have said at the beginning and I didn't. The IXLs come from Algebra 2. We're doing some Algebra 2 stuff. So please make sure that if you are using the app where you have to actually find it yourself, or I don't remember, one of them didn't show my recommendations. If you're not using my recommendations and you're looking it up yourself, make sure you change your class to Algebra 2, or you're going to be doing the geometry ones, and it's not going to be right. So make sure you change it to Algebra 2 or click on my recommendations so you can just pull it from there. All right, guys, have a great week. Talk to you later.